Hello everyone. So for this video, we will be discussing the overview of analysis of variance or simply ANOVA. So specifically, we will discuss ang one-way ANOVA. We have two-way ANOVA and other designs because marami pang designs ang analysis of variance. So what is ANOVA? ANOVA tests if the means of the groups formed by values of the independent variable or combinations of values for multiple independent variables are different enough not to have occurred by chance. It expresses a measure of the total variation in a set of data as a sum of terms, each attributed to a specific source or cause. Okay? So yung ating analysis of variance or ANOVA ay test kung may significant difference ba yung ating independent variable. So going back dun sa mga previous discussions natin, lecture videos, so yung ating independent variable refers to the treatments. Okay? Kung magkakandak tayo ng isang research or study, we assign treatments or may gusto tayong i-introduce na bago, meron tayong i-introduce na changes, meron tayong i-introduce na innovation. Yun yung ating independent variable. And they come in a form of treatments. Okay? Kung experiment yan, meron tayong treatments. And we wish to understand, no, to test kung yung ating mga treatments are significantly different ba or hindi. Halimbawa, meron tayong treatment 1, iba ba ang effect niya sa treatment 2, iba rin ba ang effect niya sa treatment 3, and so on. So we want to test kung may significant differences yung ating mga treatments. Okay? So ANOVA was introduced by Sir Ronald A. Fisher way back in 1923. So matagal na and the application has been very vast na or maraming applications na yung ating ANOVA. Normally, the ANOVA or the analysis of variance is designed to test whether or not more than two treatments, samples, or groups are significantly different from each other. Okay, sa mga previous discussions natin, we already discussed yung t-test sa z-test. And yung dalawang test na yun are limited only to testing two treatments or two means or two sets of data. Okay, so meron tayong treatment 1 versus treatment 2. Hanggang dun lang yung t-test at z-test. Dalawang sets of data lang yung kaya niyang i-compare. Pero with ANOVA, we could have 3 or more. Although ang ANOVA naman pwedeng gamitin sa 2 sets of data. Pero mas maganda gamitin siya sa more, no, sa 2 or more sets of data. So we have T1, T2, T3. So we have 3 treatments na gusto natin i-compare. So, yan ang application ng ANOVA. More than 2 treatments ang kanyang application. Ang limitation ng ANOVA, ang magiging result natin is we only determine kung significantly different or hindi yung ating mga treatments. So, kumbaga, different ba ang result ng T1 sa T2, and then ang significant different ba ang T2 sa T3, and T1 to T3. Okay? So, we only compare kung significant or hindi yung differences. We could not point out yet kung saan sa mga treatments ang best or least performing. So, yun yung limitation ng ANOVA. So, sasabihin ng ANOVA or i-conclude lang natin at the end kung may significant difference or wala. We could not yet point out kung saan sa mga treatments ang best or least performing. Okay, so hanggang dun lang ANOVA, significant or not ba yung differences. Okay, maraming designs ang ANOVA. The first of these is yung tinatawag na one-way ANOVA. Other books are using the terms na univariate, simple or single classification, and one-factor ANOVA. Okay? So yung tinutukoy ng one dyan, ng one-way or one-factor, is the independent variable. So isang independent, okay, or isang set of treatments. Okay, so let's say meron tayong study on fertilizer. So yung fertilizer yung ating independent because yan yung iti-test. Okay, so isang independent variable. Okay, so isang independent variable tsaka isang dependent. Yan yung one-way ANOVA. So dependent, going back doon, no, i-recall lang natin ang mga previous discussion, dependent refers to the results or yung properties na gusto nating i-measure or the response variable. Okay? So, sa example natin, kung ang independent is fertilizer, yung possible na dependent are height of the plant, weight of the harvest. Okay? So, yun yung ating dependent. So those are the results na gusto nating i-measure during the experiment. Okay, so yung one way, isang independent tsaka isang dependent. Okay? Pag dalawa yung ating independent, so magiging two-way yan, other design naman siya. Okay? Pag ang dependent ang dalawa, one-way ANOVA pa rin, pero dalawang one-way na. Okay? So, isang independent pa rin, tsaka isang dependent, that is one ANOVA. Kung may panibagong dependent, panibagong set, or panibagong distance variable, or panibagong property na i-measure, that is another one-way. One-way pa rin, dalawang one-way, kasi dalawang dependent. Okay? Pero pag naging dalawa ang independent, another design. Okay? So, yun nga, sabi ko kanina, ang one-way dyan is tumutukoy sa ating independent. Okay, so tatlo ang design ng ating one-way ANOVA. We have CRD, CBD, and LSD. Okay, so ang CRD or the complete random design or completely randomized design, so ginagamit siya pag ang ating mga studies or experiments are homogeneous. So pag sinabing homogeneous, uniform. Uniform ang ating samples, uniform ang experimental units, yung ating settings are uniform. So pantay-pantay tanan, no? Lahat ay pantay-pantay. Ang only different lang are the treatments. Okay? So yung treatments lang yung nagkakaiba. All the rest of the values or yung ating mga properties or settings are uniform lahat. Okay? So example, we have a study on the brick production. So magproproduce ng brick from coconut husk and clay. So in this case, yung ating independent variable are the treatments, and yung ating independent are the mixing ratio. Kasi if we read the treatments, no, ang treatment 1, 75% coconut husk, 25% clay. So mixing ratio ng coconut husk and clay. So ang treatment 1, 75-25, treatment 2, 60-40, treatment 3, 50-50, and treatment 4 is commercial bricks or 100% na clay. So yung ating independent variable is the mixing ratio, and specifically we have 4 treatments under the independent variable. So isang independent variable, isa because nga mixing ratio lang. Okay, walang ibang independent variable. Pero apat ang treatments, no? Because apat specific value naman yung ating treatments ng ating independent variable. So isang independent variable na mixing ratio. So yung ating dependent dito are the result. Okay, in this case, yung result niya is the compressive strength. Okay, so may tatlong replication or rep 1, rep 2, and rep 3. These are the specific results, okay? And the results refers to the compressive strength, okay? So that is one dependent, compressive strength, okay? So isang independent, yung mixing ratio. Isang dependent, ang compressive strength, okay? So what if marami pa tayong gustong i-measure? So assuming we want to measure the water retention, that is another dependent variable. So ibig sabihin, another one-way ANOVA, another computation yan. Okay? Kung magdadagdag pa, let's say nagdagdag ng heat conductivity, this is another dependent variable. So another ANOVA naman. So kung another property, bulk density, another one-way ANOVA, another computation. So in other words, apat na one-way ANOVA computations yung gagawin natin. Isa for the compressive strength, one for the water retention, one for heat conductivity, and another one for the bulk density. Apat na one-way. Because isa ang independent mixing ratio. Apat yung dependent compressive strength, water retention, heat conductivity, and bulk density. Okay? So yan yung ating CRD or the complete random design. Okay? So bakit siya tinawag na complete random? Because assuming na importante yung layout, let's say ilalagay natin siya sa oven, okay? So, importante ang layout sa oven, no? Kasi nga, let's say medyo hindi ganun kapantay yung pagkainit. So, ang mangyayari dyan is we completely randomize yung pagkaka-arrange ng ating mga treatments, okay? So, yung ating layout dito, we have T for the treatments, ang R is the replication. 4 treatments, that's why we have T1, T2, T3, and T4, and tatlong replication, R1, R2, R3. Okay? So kung maglalagay tayo sa oven ng bricks para maiwasan yung bias, kumbaga, so i-randomize yung pagkaka-arrange. Hindi siya dependent sa pagkaka-arrange ng researcher. So, hindi lang basta-basta ilalagay ng researcher yan. So, dapat properly naka-layout siya. So, we could do draw lots, no, or random assignment ng mga values. Okay? So, let's say through draw lots or pag-randomize, yung ating first box yan, we have the T2 R1. Okay? So, randomize ulit or the draw lots, ang next box is T3 R1. And so on hanggang makumpleto yung apat na treatments na tatlong replications. Okay? So, ganito na ilalagay sa oven because that is the final CRD layout ng ating study. Okay? So, kung ang mga studies are important yung mga layout. So, we have to make a proper layouting. However, hindi naman lahat ng studies are properly requiring proper na layout. Especially kung hindi naman sila nasa open spaces or sa field work ng mga activities. Okay? Kung field work, normally, ang ginagamit na design natin is the RCBD or the Randomized Complete Block Design. So in this case, we put them inside blocks. Okay? So ginagamit ng RCBD when subjects are matched on some variable. May tinatawag tayo na nuisance variable. Ito yung variable na hindi makontrol. Because sa CRD na layout or sa CRD na design, dapat kontrolado lahat. Homogeneous nga, sabi kanina, or uniform lahat. Pero, if we know na may variable na mahirap i-control, na mahirap gawing uniform, o hindi talaga uniform, we put them in blocks yung ating treatments or RCBD yung ating magiging design. Okay? So, ano ang ibig sabihin ng blocks? These are the levels at which we hold one extraneous factor fixed. Okay? And blocking is putting experimental units that are homogeneous or similar together. I-group natin yung mga similar na mga properties. Okay? So, halimbawa, okay, meron tayong area, field work, okay, or sa open space yung ating study. Okay? So, assuming yan yung garden plot natin or lupa na pagtataniman. And assuming na isang part dyan is less fertile. Okay? So, yung kabilang side ng ating plot or ng ating area is more fertile. We know that. Okay? Kung CRD, hindi siya pwedeng gamitin because meron tayong gradients. May pagkakaiba sa fertility from less to more fertile na lupa. So, hindi siya pwede CRD because ang assumption ng CRD dapat homogeneous or uniform lahat. Okay? So, how do we make that uniform? Kung paghahaluin lahat-lahat ng lupa, kung imimix yan thoroughly, ibig sabihin, mahalo ng mabuti, so more or less magiging uniform na yung ating plot or lupa. Pero pag malawak yan na area, we could not do that. We could not mix the entire land, no, para lang maging homogeneous. Okay? However, kung proper yung ating experimental design, maiiwasan yung bias because of that gradients ng fertility. Okay? So, assuming CRD ang ginamit, ano ang magiging possible na layout? Okay? So, let's say meron tayong tatlong treatments and tatlong replications na study. Okay? So, we have T1, T2, T3, and R1, R2, R3. Okay? So, kung randomize yan, complete random design yan. So, magle-layout lang tayo ng 9 na plots. And then draw lots or i-randomize yung assignment. Okay? So, let's say ang first box natin, T2, R1. Okay? Ang second box, T3, R1. So, that is because we randomize that complete yung pagkaka-random. Okay? So, yan, assuming naubos or natapos na yung pag-draw lots or pag-randomize. Okay, so yan yung ating final layout using the CRD. So, ano ang possible na problema with this layout? Okay, so ang problema nito, if we compare or observe natin yung less fertile na lupa. Okay, so if we can observe, dalawa yung T2 na nailagay sa less fertile na lupa. Okay? Dito naman, sa kabilang side, sa more fertile na lupa, dalawang T3. So, sa pagkaka-assign pa lang ng plots, meron ng bias. Because less fertile ang karamihan sa T2 at more fertile ang karamihan sa T3. So, yung pagkaka-assign pa lang ng mga plots meron ng bias and hindi siya dapat. Okay? Hindi siya pwedeng gawin. So, ibig sabihin, hindi appropriate yung CRD na layout because nagkaroon ng bias sa pagkaka-assign ng mga treatments dun sa ating lot or mga plots. Okay? So, paano maiwasan? So, ang gawin is i-block or i-grupo yung ating mga treatments. Okay? So, paano siya i-grupo? Okay? So, using RCBD, okay, RCBD tayo, so iba-block. Okay? So, ang magiging block natin, so dapat yung less fertile na lupa, 1 block yan. Okay? So, lahat dyan is R1. Okay? Ang average na fertility, another block. So, lahat sila R2. Okay? Ang more fertile or pinaka-fertile na lupa dyan, we have R3. Okay? And if we observe yung ating kada block, each block merong tatlong treatments. Kompleto ang tatlong treatments sa each block. So for the first block, merong T1, T2, T3. Ang second block, merong T1, T2, T3. Ang third block, may T1, T2, and T3. So, hindi na siya bias because lahat ng treatments na assign sa less fertile, sa average na fertility, and then sa most fertile na area ng lot. Okay? So, yan yung kagandahan ng RCBD na iwasan yung bias because of the factor na mahirap i-control. In this case, yung fertility ng lupa, mahirap i-control. So, we place them in blocks. Okay, so igugrupo yung ating mga treatments. Yun yung ibig sabihin ng blocks. I-group yung ating treatments na pareho silang magiging homogeneous, yung ating mga samples. Okay? So, ganyan. So, normally yung RCBD, pag nasa agriculture or field works, yung mga studies, RCBD agad-agad yan. Pero, pag controlled yung setting, let's say, nangyari ang study sa loob ng greenhouse, more or less controlled na yon. So, pwede ang CRD pag naka-greenhouse or pag nasa loob ng laboratory. Okay, CRD na siya because controlled na yung conditions. Pero pag hindi siya controlled, nasa open space, no, or nasa field work, that is RCBD agad-agad. Okay? So, yan. Ito naman, another example kung hindi sa agriculture. So, in this case, merong 4 na school. So, we want to compare, let's say, itong mga test scores, no, sa reading comprehension. So, kung naiintindihan ba ng bata yung binabasa. So, we have 4 na schools na gustong pag-aralan or gustong i-compare. At naka-block na. So, yung ating mga block 1, I think these are the more intelligent na mga students because if you can observe, ito yung mga highest scores sa tatlong blocks. Ang block 2 or the average one, ang block 3 naman are not so good na mga students because ito yung mga pinakamababang mga scores. Okay? So, hindi siya randomize yung pagkaka-blocks, no? Kumbaga, na-assign yung ating mga blocks according sa intelligence level. So, block 1 is yung mga intelligent, yung block 2 are the average one, and block 3 are the less intelligent na mga students. Okay? So, ganyan. So, we do blocking para ma-minimize yung error because of the differences ng mga sampling units. Because pag hindi siya iba-block, possible na magkukos ng error or mistake dun sa final computations natin. Then another one way is yung LST or the Latin square design. O double grouping naman. So double blocking yan. Okay? So kanina dun sa ating RCBD na example, one direction lang yung fertility from right, no, or from the left side papuntang right side. But if pag gano'n naman, pataas, another direction from bottom to the top. Okay? So, dalawang direction yung gradients or yung fertility difference. Okay? So, ayan kung RCBD, kanina yung RCBD na layout natin. So, isang block dito. The R1 is the first block. So, lahat ng treatments andyan. Okay? So, walang problema with this side. Okay? Because ang less fertile, kompleto yung tatlong treatments. Yung R2 dyan or the second block, are kumpleto ang tatlong treatments, T1, T2, and T3. Sa R3, kumpleto rin ang tatlong treatments. Okay? So, but if we compare or if we observe yung row naman, sa more fertile na lupa, okay lang because kumpleto merong T1, T2, and T3. Pero dito sa mid average, merong dalawang T2. Sa less fertile na lupa, meron tayong dalawang T3. So, naging bias ulit. Okay? So, hindi siya bias sa left to right na direction, pero naging bias siya from bottom to top na direction because dalawa yung direction ng gradients. Okay? So, kung LSD yan, so ang mangyayari, dapat once lang mag-a-appear yung ating mga treatments per row and per column. Okay, so parang Sudoku. If you are playing Sudoku, you will observe na once lang mag-a-appear yung ating mga numbers sa isang column at isang row. So, just like this one, T1, T2, and T3. Okay, so that is the top row. Sa mid row, T1, T2, T3. Sila ulit. No? So, sa bottom na row, silang tatlo kompleto. Okay? So, kung column naman, first column, kompleto ang tatlong treatments. Sa second column, kompleto ulit ang tatlo. Sa third column, kompleto ulit ang tatlo. Okay? So, once lang nag-appear sa isang row at isang column yung ating mga treatments. Okay? So, mas less na yung effect ng errors because sa pagkaka-assign ng blocks. Okay? So, yan yung kagandahan ng Latin square design or the LSD. Okay? So, ito yung ating mga layouts. Pag one-way ANOVA yung ating study, either CRD, kung homogeneous yung ating study or controlled lahat ng units and the setting, ang RCBD naman or the randomized complete block design, pag iba-blocks natin in one direction. Okay, ang Latin square design naman, pag two direction or double blocking or grouping tayo. Okay, and normally ang RCBD and LST is ginagamit for agriculture or mga field work studies. Okay, then we have also ang two-way. So pag sinabing two-way, one dependent, pero dalawa ang independent. Okay, so dalawa na yung kind of treatments na gusto natin i-test. At ang result ng two-way, meron tayong tinatawag na main tsaka interaction effect. Ang main effect, direct effect, no? Kung ano yung ating independent, ang kanyang direct effect, that is the main effect. Pag nagkaroon ng fusion or joint effect, yun yung interaction effect. No, joint effect ng two or more independent. Okay? So assuming ito yung ating study, kanina ulit, balik tayo dun sa bricks. So yung ating factor A, so the first independent is the mixing ratio. So ito ating mixing ratio ulit, 75-25, 60-40, 50-50, and 100. Pangalawang factor, or the second independent, assuming merong firing time, or kung gaano katagal yung oras sa pagdadry or firing kasi pagpaluto ng ating bricks. Okay? So let's say 10 hours, 12 hours, 15 hours, and 18 hours. And if you can observe, lahat ng treatment sa factor B must appear sa each treatment ng factor A. So kung ang 10, 12, 15, 18 na-assign sa factor sa 75-25 na ratio, dapat ganun din sa 60. Okay? Because complete yung ating design dapat. So 10, 12, 15, 18 ulit sa 50-50. And the same factor B na treatment sa 100% na clay. So masyadong mahaba or marami tayong treatments niyan. Okay? So gaano kadami yung ating treatments. Okay? So ito na yung sinasabing main effect tsaka interaction effect kanina. So ang main effect, so ang mixing ratio, that is the main effect. So which of the four treatments significantly different or hindi. So pwede kasi yung ating result significant sa mixing ratio. Okay? Pwede rin yung ating result significant ang firing time. So mamimili tayo kung saan dun sa firing time ang the best or hindi. Later on, no, sa after the ANOVA. Okay? Kung may significant na difference or wala yung ating result. Okay? So ito yung ating main effects because these are the independent variables, mixing ratio tsaka firing time. Yung interaction effect naman, yung effect ng interaction ng treatments. Okay? So halimbawa, itong 75, 25, so ipa-partner dun sa ating mixing ratio, partnered with the firing time. So 75, 25, 10 hours. Another is 75, 25, 12 hours. So joint effect. So that is the interaction effect. Joint effect ng dalawang main effect or ng dalawang independent variable. Mixing ratio plus the firing time. So ito na sila yung ating total treatments. Ito sila lahat yung ating treatments na gagawin. So masyadong marami. Okay? So that's the disadvantage kumbaga ng mga two-way or multifactorial design, especially kung complete blocks. So maraming samples or maraming treatments na ipe-prepare. So in this case, ilan yung ating treatments? We have 4 na factor A. Okay? So 4 na factor A and then 4 na factor B. So that is 16 treatments lahat-lahat. Okay? Kung tag 3 replication sila, so 48 lahat. Okay? So kung gagawa tayo ng bricks or units, so we have to create 48 bricks. This is for one dependent. Okay? So kung compressive strength yan, 48 bricks lahat yung gagamitin for compressive strength lang. Okay? So yan, destructive yan ang compressive strength. So if we have another dependent, let's say ang dependent is yung water retention, so ibababad sa tubig, so we have to prepare another set of 48 bricks for another dependent, which is yung water retention. Okay? So ito yung challenge no ng two-factor. Maraming treatments and maraming units or experimental samples yung magagamit sa study. Okay, so ayan, so mas complicated na if we go to 3 or more or the N-way or multivariate ANOVA. Okay, so ayan mga unique design na ANOVA, we have yung split plot design, so we have also the strip plot, split plot, and the strip split plot. And normally, sa mga agronomic studies, ginagamit itong mga ANOVA designs na yan. So, yun, going back dun sa ating example, so let's say ang ating factor A mixing ratio, 4 na treatments yun. Ang factor B firing time, 4 na treatments ulit. So, what if nag-introduce tayo ng pangatlong independent variable, let's say firing temperature. So, temperature naman yung itetest. So, let's say 4 din na temperature. So, ilan lahat yung ating treatments? 4 times 4 times 4. Or that is 4 times 4 times 4, that is 84. Okay? So, kung baga, ganun kadami yung magiging treatments natin. Okay? So, I mean 64. So, we have to prepare 64 treatments. 4 times 4 times 4. So, 64 treatments lahat. So, kung tag 3 replication times 3, that is 192. So, 192 bricks yung gagamitin. That is for one dependent. So, kung compressive strength yan, 192 yung gagamitin bricks. That is for complete factorial design. Okay? Kung may another independent tayo, may water retention, another 192 bricks. And so on. So, the more treatments, the more dependent, the more samples or experimental units that we have to produce. Okay, that is the challenge for multifactorial analysis of variance ng mga design. Okay? So, I hope you understand yung overview ng ating ANOVA. Okay? For simplicity, normally we take one-way ANOVA. Although yung two-way tsaka multi-way variant ANOVA, meron naman mga specialized design para ma-minimize yung preparation ng maraming sample units. Okay, so for our next lecture videos, doon naman tayo sa specific designs ng one-way ANOVA.